it's time, is it? Time?
Yeah.
Yeah. Okay. All right, this is the Saag session. If you're here for that, then welcome. If you're going somewhere else, then now's the time to do that. So I think the blue sheets are coming around. We have a JavaScribe as Phil. You have to get him another star. And Hannah's and Mike are going to take some notes, so we're covered in that respect. There's the note well. That's our agenda. There's a couple of other pieces on the agenda that are not in the slides, but are on the other copy. Just a couple of like 1 and 5 minute notifications. So I think Paul Wouters is going to just talk for 1 minute about his IPsec stuff, and then I think Eric's going to talk a little bit about some video conferencing stuff. That's for like a couple of minutes as well. Any agenda bashing? Nope, great. Okay, so working group reports. So if you've already sent a mail to the SAG list with a brief report, then there's no need to stand up. If you haven't, then please, somebody could tell us just what happened or what's happening in that working group. So, and I can't see the mailing list, so I can't remember who sent what. So, was ACE reported on? ABFAB didn't meet. Is there anything to report?
We're really soon done.
Good. Real soon. You hit that close button. Dane, did we get a report sent? Don't know. Oliver and Warren are not here. Paul, but you'll do fine.
So I wasn't prepared, but so basically most of the Dane working group discussion, we started off with an announcement of an implementation of the SMIMA stuff, where you can go and get certs and such like that from VeriSign Labs. But most of the discussion was about one aspect of the OpenPGP format that was causing a lot of problems. We had a bunch of applications people invade the working group, sort of like security people sometimes invade application working groups.
So there's an interesting discussion to be had. I guess it's ongoing. DICE did not meet. I don't know if Zach is here. No, I think their work on the profile is getting towards the end, I guess, and working group last call is complete. So that. Okay, so the profile work is getting done, and the other part of the chartered work we'll have to look at again, I guess, and see what we do. HTTP auth, I think there was a send a mail, good. IPsec me, good. Jose, I think I saw one of those. Kitten, good. Mile, anybody know? Anybody want to tell us what happened or? Going, gone? We got them, okay. OAuth was sent, I remember that. SACM. Okay. TLS we did get. Tokebind. Sent, great. Trans, fantastic. Okay, related working group, there's a bunch of them around the place, and this may not be a complete list. Is anybody, so Anima is doing some work on kind of provisioning and more certificate stuff? Okay.
Hi, Stephen, this is Nancy.
Oh, there you are.
So I did send a very quick report. So Anima on Tuesday, they reviewed a couple of bootstrapping. There's an actual draft on zero-touch bootstrapping. There was another presentation from the NetConf team and how they could achieve some similar effect. There was a survey that was also presented on how to do this. Discussion on the security properties there. And then on Friday, they're going to meet again to talk about the reference architecture and models.
Thank you. TCP Inc. I said it already. Oh, okay, great. HTTP BIS, anything to talk about there? Martin, you look like you want to?
Martin Thompson. We're done with HTTP2. Thanks for all the help from people here. And there's some content encoding encryption work that may or may not be starting in it. And we've had a couple of people already working on us try to disabuse us of any notion that we might develop a new format. But please take that to me or Mark Nottingham for the time being. That hasn't been discussed a lot, but it's coming up.
Great, thank you. And DPrive or DNS op, there's some privacy related stuff. Anybody want to speak to that? I wasn't at DPrive. Who was at the DPrive meeting? Thank you, Paul.
So DPrive has 3 completely separate proposals in front of it that we need to decide between. There were presentations on each. There was a hum at the end that sort of ended up that the working group was okay for now with coming up with 2 or 3 solutions, not just one, that would get pared down later. And DNSOP had a lot of stuff about, more about DNSSEC, ways of getting DNSSEC to be a little bit easier to be deployed. I think that was about it for DNSSEC there.
Thank you. UTA? Sent a mail, that's great. So actually,
one more additional flag on DNSOP. Folks might be interested in. DNSOP is currently discussing registration of a variety of possible special use domains, among them .onion, which is used by Tor hidden services. So security folks might want to tune into the DNSOP list for that discussion.
and so they discussed that, and I think somebody told me it went well, whatever that means.
Yeah, I think there was a generally supportive vibe in the room. Discussion was really short, and they're going to plan an interim on the topic. So
Okay.
there may be latent disagreement that will show up there, but the general vibe at the meeting this week was pretty good.
Okay, and I guess that should be CIDR, but isn't. Sorry, apologies for misspelling your acronym.
Sandy Murphy, Parsons talking for CIDR. Met on Monday morning. Some documents are progressing, which is good. The protocol document went through working group last call, and they're addressing the comments. Actually found a substantive one, which is good. There was a presentation about a survey of RPKI and DNSSEC deployment, why and why not, that was announced on the CIDR list and at NANOG, and there was a report about some of the results from that survey. They were kind of interesting. 15% of the both, 15% both for RPKI and DNSSEC said they never heard of it, and these were 200 ISPs, Transit, so kind of like, oh, good grief. And 10% in both cases thought that these were evil plots on the part of authority to give people handles to squash things. And, so some interesting results. You may want to take a look at the slide.
Okay, thank you. And CF4G? Okay. I hope so.
So CFRG met Wednesday afternoon. The meeting was very well attended. We need a bigger room next time, please. We had presentations and discussions on 4 different topics, and the most important one, I think, was elliptic curve cryptography. I'm happy to report that we're making good progress now on selecting curves and algorithms to recommend to the TLS working group. We also had an update on scrypt, a presentation on hash-based signatures, which is a new line of work starting up in the group, and some work ongoing on PAKE, Password Authenticated Key Exchange, where we're starting work on a requirements document and also looking at some specific PAKE protocols. Thank you.
Thank you. So we've come to the boss, but any other existing working groups that should be on this list that there aren't? Nothing right now? Okay. Buffs. We had dots. I think, say again? It's on the list already. Nobody wants to talk about it? Great. Acme. Did we get a mail, or does somebody want to say what went? Rich said, okay. Richard's at the...
Oh, John's good. Yeah, I mean, can say more about DOTS. The summary is on the list, but in summary, there is consensus that there's interest in the IETF pursuing some standardization for on-premises mitigation devices and that communication with service providers. Folks expressed interest in doing kind of that work since this was a non-working group forming BOF. All excitement, interest, and enthusiasm should be taken to the list to figure out the next steps.
I guess Richard's going to talk about ACME.
Yeah, I think the ACME BOF was pretty well attended. We got a lot of folks in the room from a bunch of different constituencies and got some good feedback on the initial round of proposals. I'll, of course, leave to the area directors the final decision about what the vibe was, but I think that there were some humps at the end that ended up being pretty supportive of moving forward with some work in this domain. I think the plan is to hash out some charter text on the ACME list. And what was the plan you expressed there, Stephen? To maybe go for a working group in sometime by Prague?
In a few months, yeah. And then so one that should have been on the other list, I guess, is DIME and RADEX, which are now, Kathleen is helping, even though they're in the ops area, I guess. And I think Lionel sent mail about both DIME and RADEX.
Yeah,
Lionel, are you here? Or Yoni, sorry. Yeah, so they're looking for some help in DIME to do some end-to-end security stuff. And so if you're interested in Diameter and helping them to do some more crypto things with it, then please help. I think the reason they need help is because you're no longer helping. Okay, there was a couple of side meetings. I2NSF was a BOF last time and had a side meeting this time. And I don't know, did Dan or somebody send a mail to the list? Or if anybody wants to speak to it now?
I don't think we sent a mail. We had a meeting last night and further discussion on use cases, and there's a framework being worked on and making some good progress, but still some more to go before a BOF, hopefully next time.
Okay, thanks. And there was one on PGP. Derek, do you want to say hi?
Derek Atkins. A bunch of OpenPGP enthusiasts met on Monday evening after the plenary to follow up on a bunch of discussions that have happened on the list. A lot of ideas were tossed, but I don't think there was any particular consensus on any one thing to do. So I don't know what the next steps are going to be, if any. But there's definitely interest in doing something, but different people want to do different things.
And I think I saw Mark Nottingham come in. There was a captive portals kind of discussions somewhere. There he is. Grab a mic.
Yeah, Monday night we had a barb-off for captive portals, trying to figure out how to improve that fantastic situation even more. And we had a good representation of operating system folks, as well as networking folks. We decided to set up a mailing list. It's just captive-portals. And there was some focus on a draft that's in the ops area that's being AD sponsored, I think, for a new DHCP option to identify a captive portal, which seems promising, got a lot of interest. We're not limiting ourselves to that. We're trying to figure out other things we can do to improve the situation. And we've also been reaching out to captive portal vendors. So, and also the W3C is interested in this as well. So hopefully we're just going to get a critical mass of enough people globbed together to do something or kill us all.
Cool. And I know there's, I think people were going to meet to talk about what Ladar will be talking to us about tonight or something. Was that right? Okay, so but you're going to be talking anyway, so we don't need to do that. Any other kind of interesting side meetings that went on that somebody wants to tell us about? Paul again?
I don't see the people who called it. So last night, a bunch of people got together to discuss SSL VPN, TLS VPNs, and trying to describe them.
Yep.
And it went sort of all over, and that might actually happen. I think they're going to ask you to give us a mailing list.
Yeah, Mike Boyle, NSA, I got up to basically say the same thing. I think we had a good discussion. I do think maybe, we're all over the place on what TLS VPNs are, and I'd like to explore maybe kind of narrowing what we mean by saying that. And yeah, we may be coming to ask for a mail list.
Those are cheap.
Thanks.
Gabriel Montenegro.
So there's a side meeting that's going to happen tonight, 7 to 8. It's purpose to discuss security problems and issues related to IoT. Particularly, this comes out of the 6th Flow working group.
And did you say where it was on?
I forgot the name of the room, but it's basically the room up on the terrace by the pavilion.
Pavilion room, okay.
Yeah, so it's IoT, for people who have IoT and security interests.
Yo?
And one more, yesterday we had a SDN off meeting, same time as the plenary. Well, this time as opposed to the previous times, we had a lot of more SDN clue in the room, and it turned out that a lot of the terminology was wrong, and well, there was a summary sent to the list. It's mostly about transferring information about authorization and authentication between applications rather than controllers, as was previously stated. And so the Hosnia is organizing this. Will think what to do next with this thing.
Okay, thank you. So I think the next was Kathleen's.
Thank you. Does it help to stand or? So we just wanted to give a summary on the pervasive monitoring drafts and our progress so far. We've been doing a bunch of things, and there's work going on across a lot of different working groups, including one that just passed by me for opportunistic security and IPsec, so that was kind of cool to see some of this stuff actually going into protocols, so good job, guys, thank you. So we have the 7258s and confidentiality in the face of pervasive surveillance. And then I'm working on a draft, and this is really just to ask for, you want to advance one? Just to ask for contributions. So we tried to write this draft, myself and Al Morton, in a very neutral way so that we could get submissions from both security and operators to list out types of monitoring that happens in networks, and it might be security, it could be operations, the purpose of that monitoring, what's used in that monitoring, and if it's broken with encryption. This is not going to try to fix anything, and in some cases you will not be able to fix and be able to do the types of monitoring, but by documenting this, maybe there are alternate ways that other folks may come up with to help solve your problems, and it may not involve monitoring, there may be some innovation. And maybe there won't be, but this is I think it's an important next step, because as encryption gets more pervasive, we run into problems where people are trying to break it to continue to do their monitoring. So if we could acknowledge what they're trying to do and then figure out the problems up front, maybe we could avoid some of that.
Yes, hi, Natasha Rooney from GSMA. Thank you so much for this work. A lot of operators have read it, and we'll send some more input into that at some later phase. I wanted to speak to you about it previously, but haven't had an opportunity up until now. So thank you, for this.
Awesome, thank you.
Paul?
Yeah, I would also like to say the same thing. We had a very big customer that was also really happy to see that apart from us encrypting the network, they now actually had a document that they could tell all their peers why they're doing this, and that the inconvenience of that is really worth it. And this is a really good document for that.
Yeah, I agree. Okay, and then nothing else that. Presentations. So, Joe, I think you're first. He has to go stand in the pink box.
Wait till I get your slides up. Is there some kind of slide clicker, or is it going to be me saying click?
It'll be you saying click.
Okay, great. Great, everybody can hear me? Great, so yes, I'm Joseph Bonneau. I'm a postdoc at Stanford and a tech fellow at DFF this year. I'll be talking about some research I did last year while I was at Princeton. Basically, I had a master's student for the summer, and I said, wouldn't it be cool if we looked at HSTS? It's been around for about 5 years now. Let's see who's using it, how it goes wrong, and then we threw pinning in for good measure, because pinning's also cool. So I'll just talk about what we found in terms of HSTS and pinning, what a couple of the bugs were, and how many people are deploying them, what they're doing. Click. Great. So the really quick refresher, HSTS is just trying to prevent stripping, which is a really simple man-in-the-middle attack where the man-in-the-middle replaces an HTTP connection, relays an HTTP connection to the user and an HTTPS connection to the server. Next, please. And the user will only notice that this relies, preventing this relies on the user noticing that the connection's been downgraded. There have been a bunch of usability studies that suggest this never happens. This is basically where HSTS came about, which is the idea that the domain can just say, I never want to be in this situation. The client should learn that it should always have an HTTPS connection to my domain. Next, please. So there's basically two ways for your client to learn this. One is through a header, a very simple header, and the other is through preloads that are built into the browser. So this is just a snippet of the preload file that's in Chrome. Firefox has quite a similar list now. And if you like, you can think about a project like HTTPS Everywhere as basically a way for your client to learn even more policies, even though technically those two things are pretty distinct. So in a perfect world, these two will go together. You can think of the end-to-end picture for HSTS security as your browser starts off with some preloads, knowing that there's some domains that it should always talk to over HTTPS. And then you can navigate around, you can find new domains, and security will be protected. And then there'll be some HTTP domains or some domains that weren't preloaded that you never pick up the security flag for. Right. So the other thing I said I'd be talking about would be pinning. This is to prevent a more powerful adversary who is doing a man-in-the-middle attack, but this time we assume the adversary actually has certificate authority compromised, so they have the ability to mint rogue certificates. So they're now doing a man-in-the-middle attack where they just replace the genuine certificate for the domain you're trying to go to with one issued by a different certificate authority that they have actually issued just for this attack. So the solution to this, right, and of course, similar to the case with pinning, relying on the user to detect this is a non-starter, actually much worse than pinning because the user would have to not only notice that the padlock, it's not as simple as noticing that a padlock isn't there, the user would have to actually dig into the certificate settings, look at who the CA is in the cert, somehow know that that's wrong. So pretty fair to say, even though I actually don't have an academic paper to point you to, that users definitely are never going to do that. So the solution to this is pinning. So the idea behind pinning is pretty simple. Your client just needs to learn what's called a pin set for a given domain, which is a list of hashes of SPKIs and certs. And it's a fairly simple mechanism which is actually quite flexible. The rule is this. For a pinned host, so again, you'd have that pin set, which can be arbitrarily long. If you're going to accept a certificate chain, at least one of those pins, at least one of those public keys has to appear somewhere in the cert chain. So on the left here are two examples of cert chains that would satisfy this pin set. One by having the public key in the actual server cert, the end entity cert, and one by having it in the certificate authority that actually signed that cert. What won't work is if you have a completely different cert chain that doesn't have any of the public keys in the pin set. And what also won't work is if you have a cert chain that actually has one of the public keys from the pin set but isn't anchored in a trusted certificate authority. So a lot of the time when a misconception I see is that people think pinning is a way for them to not have a certificate that's signed by a trusted certificate authority, but it doesn't work that way. So just like with HSTS, there are a bunch of preloads now in the browser. So a little bit more complicated now. You specify a pin set, and then the pin set is basically a list of public keys there. And then elsewhere, for each of these public keys, there's actually a hash of what that certificate should look like. And I guess it's worth putting a technical note in here that even though this preload file is basically a JSON file, it's not actually parsed by the browser at runtime as JSON. It gets compiled into a C++ header file. So just like with HSTS, you can also set pin sets via header. It's essentially the same format. The only difference now is that it's not simply, it's not a one-bit policy. You have to actually specify a bunch of key hashes here. So the header ends up being a little bit bigger and more complicated. You can see I've cut some of the detail out there, but in this header you actually specify a list of key hashes that make up the pin set for your domain there. And you can use SHA-1, you can use SHA-256. Those are the two options right now. So the risk with pinning that you have to be very careful about, if an attacker is able to issue pins first and then somehow destroy those keys, there is this big concern that they can brick a domain, and any client who's picked up that bad set of pins will not be able to access that domain basically forever until either that those pins expire or something crazy out of band happens. So certainly on the working group for pinning, this has been a big concern, is hopefully that this won't happen. Okay, so I'll move into our research, what we found in terms of deployment and in terms of bugs. So HSTS, that's been a standard for a couple years now. All the browsers support it except IE. IE has committed to supporting it, so hopefully a year from now this slide will be different. So we crawled in a couple different places. We actually, using ZMap, we did a scan of the top million Alexa domains, looking for HSTS. We also crawled everything that was in the preload list. And we did a little bit of spidering to try and find domains that were doing it, and we found a little over 12,000 domains that are setting an HSTS header. And I'm sure that number is a little bit bigger now. All the numbers I'll give you in this talk are from the time we did the crawl, which was November 2014. So pinning is a little bit later. It's just a proposed standard right now. It's not finalized. The browsers don't actually support the pinning header yet. So we did see some sites that are actually setting a pinning header. None of the major browsers actually implement it yet, so that header is basically just being set for testing purposes or by enthusiasts. When we drilled down, most of the people who are setting these headers, it seemed to mostly be security bloggers' personal web pages at this point. So I won't have very much interesting to say about HPKP headers in practice, but I will talk a little bit about the preloaded pins. Okay, so this is a graph that we made by looking at the history of Chrome's source tree. Just looking at how big that preload file has been in Chrome and how it's grown over time. So the two big events here. So these bottom lines, the solid lines there are all HSTS. The top line, the dashed line, is pin sets, but the axis is on the right, so it's actually not more. It's only like 10 domains, it's a lot more than 10 domains. It's only like 10 sets of pins. They end up affecting a lot of domains because Google alone is a couple hundred. But two big events here. So on the left there, around September 2012, there's a big jump. That was Google turning on HSTS and pinning for a lot of its domains at once. And then you can see that in the fall of 2014, there was this nice big uptick. And so the reason for that, next slide please, is that prior to that point, to get in the pin list was kind of an informal process with a very special individual who's in the room with us today. Since then, it's actually been formalized a little bit. So if you want to get your domain into the Chrome list, you submit your domain at this site here, and within a fairly short period of time, but certainly not instantaneously, Google will go and crawl your domain. If it satisfies all of the conditions that are laid out, then you'll be added to a future version of Chrome. Question?
Slight correction. I can't verify this independently. You have near chair of website, among other things. I've been told that Chrome already supports the HPKP header and that Firefox has the code for it, but it's not in the public versions.
So maybe we don't want to take too many questions right now.
Sure, yeah, I was under the impression that it was like the code was mostly written but not turned on, but if it's been turned on,
HPKP has been in Firefox, I think, for a couple versions now.
Okay. Okay, great. So correction, it's now been turned on.
And if anyone wants to get preloaded, you can talk to me.
Yeah. Right. So fantastic. So I'm pretty sure at the time we did the research in November, maybe we were one version out of date, but we were playing around with it and couldn't get it to seem to work. But hopefully that's great news if it's turned on now. Right. So drilling in a little bit more. It's worth noting that the requirements to be preloaded go a little bit above what the standard actually says. So in particular, if you want to get preloaded, you have to set, there's a minimum time to live that you have to set for your HSTS header. You have to add this special preload token. And probably the most interesting thing is that you have to specify include subdomains. So that's optional in the standard, of course, but to be preloaded, you now have to set it. Right, so this is just kind of basic stats, but this shows that there is a pretty good mix of stuff. So there's both domains that are pinned but not preloaded, so they have key pins, but sorry, the way I said that wasn't very clear. There are domains that have HSTS preloaded but not key pins. There are domains that have pins but not HSTS, and obviously there's quite a few that have both. So basically every combination we saw a bunch of. Okay, so this is basically how popular the sites are that are preloaded, and we broke it down between the Google domains and the not Google domains, just because by sheer number of domains in the list, the Google domains are still quite a large number with all the various country codes that they have. So I think the high-level takeaway here is just that it's not the case that all of the sites that are being preloaded are the most popular sites on the web. There's a lot of uptake among very small sites. So these are the basic stats on the pin sets that were in the Chrome list as of November. So this is a little bit different. This is mostly fairly big sites that are setting pins. I think one of the interesting things here is that in the case of Dropbox and Mozilla and Twitter, these pin sets are really big. So the biggest one is Twitter CDN, which is for their content delivery networks. And there are like 40 different keys that, and remember, it's kind of a disjunction. So if any of those keys are anywhere in your cert chain, then the cert can be accepted. So, I mean, it's a fairly big pin set, although you can still say that it's narrowed down the scope of CAs that they trust by quite a lot. The other thing here is that most of the sites that we looked at are mostly pinning to CAs and not pinning to end entity certs right now.
Sorry, my understanding of the HPKP was that you needed to actually have multiple pins set in order to be pinned. The LavaBit line there suggests that LavaBit has no redundant pins.
Yeah, so that's so the difference there is for the preloads in the browser. These are all the preloaded pin sets, not the dynamically set ones.
So preloaded pin sets don't need to be redundant?
It's not. Yeah, I mean, there's one in there that's not redundant.
Preloaded pin sets can be whatever you can convince me to put in.
Yeah. So that may just be the one exception that will never be done again. Who knows? But yeah, it is a good point that for dynamically set pin sets, the minimum size is 2, at least according to the standard. Right. So one question we had was how up to date this list is. So we tried to actually crawl all these sites. It's mostly pretty good, but we did find about 10% of them either gave us a 404, redirected to something that wasn't secure. So there's definitely a couple of domains in there that don't quite exist anymore, including LavaBit, as was just mentioned. And I guess since we did this research too, we did have an odd situation with CryptoCat at the end of the year, which is preloaded with pins, where they actually changed certificates in a way that broke access to their own site. So as far as I know, that was the first example of somebody with preloaded pins who actually did the frightened thing of bricking themselves. Although I believe that situation's been resolved now because they got a different cert. Uh-oh, correction.
It got resolved, I kicked them out of the pinning set for that.
Oh, okay, yeah. All right. Right, so like I said, the uptake, we crawled about 1 million domains. We saw about 10,000 things. So, 1% of the top 1 million sites setting an HSTS header, is that good or is that bad? It's definitely great that, 5 years ago the number was 0. We also tried to look at how many of those sites, in a sense, could or should be doing this, because they're all HSTS, or they're all HTTPS anyway. So we did find a much larger set of sites that redirected from HTTP to HTTPS, but weren't actually setting the header.
Eric Pasquale, I'm sorry. I think I may have misunderstood what you just said. Is this the top Alexa 1 million that do HTTPS, or is this out of the population? What fraction is this?
So this is out of the Alexa top 1 million. About 1% are setting HSTS.
What fraction of Alexa top 1 million do HTTPS at all?
Oh, do HTTPS at all? Good question. I don't remember off the top of my head. I want to say it's like 30% or something like that.
Okay, so this is roughly 1 in 30 of the HTTPS sites that are less than top 1 million do HSTS.
Yeah, and about 1 in 6 of the sites that are basically only HTTPS, like they give you a hard redirect from HTTP to HTTPS, are doing HSCS.
Yeah. Jeff Hodges just echoed the better numbers are in the paper.
Okay.
Yeah. Right, so I mean, we definitely saw this as an opportunity, that there are a lot of sites that are basically HSTS ready because they're doing the hard redirect already. It's not to say that every one of those should definitely be doing HSTS. It's not advisable to do HSTS unless you're fairly sure you're going to remain in that state. But I think it's safe to say that the pool of people who, with a little bit of prodding and evangelism, might want to do HSTS is a lot bigger than the people who are currently doing it. So we also found a lot of people are trying to do it and are doing it not quite right. So the full breakdown of all the errors is in the paper. Some of these maybe aren't quite errors, but a lot of people set a very short time to live or a time to live of 0. There is actually a use for setting a time to live of 0, which is to clear out an old policy. We certainly saw a lot of people doing that. We saw a lot of people not redirecting, and we saw kind of a sad number of people who spelled it wrong, had more than one header. More than one header actually turns out to work. The behavior is just undefined, of course. Is it the last one? Yeah. Yeah, I was actually surprised how many people we saw who set more than one header. We actually got to talk to quite a few of them, and they just said that they were setting it in multiple places, and it was, we did have a lot of people get in touch with us about this paper, which was cool, and try to debug how they ended up in the paper. Yeah?
Is there a publicly available tool to test this stuff?
That's a good question. I don't know that there is. The student I had working on this was at one point planning to try to write some code for Firefox to spit out warnings for people. I think that he went to write his master's and thesis and forgot about it.
Hi, Jeff Hodges. So SSL Labs, if you point them at your website, they test a whole bunch of stuff about your SSL, and they also note whether HSTS is there. But presumably, y'all could work with Ivan and stuff, and they could do better, more full-featured reporting and stuff there.
Yep, definitely. I mean, I think the lesson is that it can be hard for people to tell when they're trying to do something and they don't realize they're not getting the security. The other bug, of course, that we saw a bunch, we saw a lot of sites that were setting it over HTTP, some of which didn't even have an HTTPS version of the site at all. So we got in touch with some of those people, and we definitely found a lot of them who thought that they were getting a security benefit by doing it. So maybe those administrators, I don't like to say people are beyond help or whatever, because we reached out and explained it, and then they got it. But it just goes to show this stuff is hard for people. Right, so like I said, we saw about 5% of people in the 0. A lot of people, about 10% are in the less than a day range. So you do get a little bit of security benefit by setting a really short value. You're basically, That's more of a sanity check. If you have like links internally in your own website that are over HTTP, you can sort of patch this up that way. But you aren't like constantly exposing the user to a new man-in-the-middle attack that way. Right, so a couple of the more subtle things we found. So if you're pinning your website, there's this kind of new issue, which is that just like you can have mixed content by including resources over HTTP in an HTTPS site, if you're pinning, you can undermine your security if you include HTTPS resources that aren't pinned in your pinned HTTPS site. So basically exactly the same as classic mixed content, except now the security gap is between pinned HTTPS and non-pinned HTTPS. So basically every domain that was pinning had this in the passive version, where they included some images over some HTTPS connection that wasn't pinned. You know, just like with normal mixed content, the dangers of doing this are maybe somewhat contained. But we also found that the active version, which is now really undermining security of your site, was pretty common. So just lots and lots of pinned websites loading scripts over a non-pinned connection.
Richard Barnes, so one of the hypotheses that I've heard a couple people express about the prevalence of active mixed content and passive for that matter is the lack of support for HTTPS and we have ad networks. Does your study, is there anything in your data that would indicate or refute that?
Yeah, good question. So next slide, I think. Yeah, so we did look at where this was coming from, and that was basically most of it is that people were loading things from some CDN or ads. In this case, that have now adopted HTTPS but aren't pinned. And so you could see, you know, in the Twitter case, they had to have this special pin set for their CDN stuff. You know, Google ended up doing relatively okay because they host most of all their own content, so all of it's pinned. But basically, all of the other pinned domains end up loading something at some point from a non-pinned external site. So it's just hard right now because none of those people support pinning. So to really have full security for a pinned website, you sort of have to have everything you depend on also pin. There's also kind of a slightly more subtle version of this, which is that some resource you include isn't not pinned at all, but it's pinned to a different set. So now this just means that the effective pin set for the whole website is expanded. So you can think of a website loading a bunch of resources with different pin sets, and there's an effective pin set, which is the union of every active resource that's loted's pin set. So we saw this a lot. Almost all of the causes of this were Twitter has two different pin sets, so effectively that was triggering the code we wrote to check for this. And also quite a lot of people were loading the Google Analytics code, which is pinned to the Google set, and if you load it in a different site, then you've expanded your set a little bit. Right, so the other kind of subtle security issue we found that was going on a lot is that people have cookies that are scoped to subdomains and they don't extend either their pinning or their HSTS policy to subdomains. So the risk here is that you set some cookie, you have your HSTS domain. By default, the cookie will be available to all your subdomains. So an attacker can try and steal that cookie if they can just get the client to make one reference to subdomain that's not subject to your HSTS policy. So obviously the ways to fix this if you're implementing a site, you either need to set include subdomains or you need to make sure that every cookie you set has the secure attribute set. And of course we found lots and lots of HSTS domains that were setting cookies without the secure attributes, and they didn't have include subdomains, so those cookies are vulnerable. So most of these cookies were pretty boring. They were tracking cookies and stuff like that. The reason is that we obviously didn't crawl a million domains with an actual user session at every domain. But we, most of these cookies not too exciting, but I speculate that a lot of these domains would have the same problem with login cookies if we had the login cookies to test. So there's also a pinning version of this, and this is tough because there is no equivalent to a secure attribute for pinning. I mean, if you could set an attribute on your cookies that said pinned, which meant don't send this cookie to any domain that's not pinned, that would be nice, but it doesn't exist. So you basically can't help yourself here if you're a pinned domain unless you either set include subdomains or you make sure that all your cookies aren't scoped to subdomains. So in this case, we actually did get login sessions since the set of pinned domains we were crawling was so low. And as of the time we did this, the Facebook and Twitter login cookies both had this problem. We got in touch. It's a known vulnerability at both places, and they're hoping to fix it by having, I believe the code has been pushed for this now, so that they can actually have their pinning policy extend to subdomains preloaded in the browser, but not their HSTS policy. That was the setup that they wanted, which wasn't possible at the time and now is possible. So hopefully for these two specific cases it's fixed now, but this is definitely going to be an ongoing problem with cookies getting an inconsistent policy to what's there for the site. Right, so a couple takeaways from this work that we had. The standard, there isn't really a holistic standard. The format varies between the preloads and between the headers. And there's sort of some weird interactions, like I mentioned, between your preloaded policy for HSTS and for pinning. The Dane and other things have a different standard, of course. So given time again, it would be great if we had designed everything to work together from the start. But that's just the web. Things aren't designed from the start; they're accreted. So, question? Yeah, go ahead.
Yeah, I would like to reopen. Sorry, Phil Baker. So I'm a bit concerned about this having two different registries, the private registries of preloaded headers. I think that information should be in the DNS. It's not true that nobody considered having one format. I did. I proposed a format in CAA.
Yeah.
I proposed that we put the HSTS data into CAA. CAA is architected so that can now be done. It's supported in bind. I suggest that we just do it. We just take the HSTS data, you put it in a CAA record with an HSTS header, and then that would be a very easy way of communicating that information through the DNS without all the additional semantics that are layered on in Dane and are possibly divergent. It is also something that if I've got reps on the phone that are talking a customer through this stuff, when we're telling them to put the CAA record in, we can do a HSTS record at the same time and get their website set up and get all three consistent.
So just a timing thing. How many more slides have you, Joe? Okay. So maybe let him get his slides.
Okay. Yeah, I didn't mean to say no one's proposed this. Actually, I have seen a couple of proposals over the years. There hasn't been momentum to try and align all of the different proposals here. So I think there's a couple places where, having talked to probably on the order of like 24 people who came up in the paper as having some configuration error in their site and talking them through it, I think better defaults that were more in line with people's expectations might have helped. So if it was up to me with dictatorial control to redesign the spec, I would have include subdomains be the default behavior and have people switch to exclude subdomains if it was breaking some functionality. It seemed that most of the people I chatted with thought that's what was happening and didn't realize that they had to actually specify this thing. So I would put out there that if you break people's functionality, they'll notice it and fix it, whereas if you break their security, they usually don't notice it. So I would lean towards stricter security and have people peel it back if it's causing functionality problems. And I also would put out there, I think that the secure attribute for cookies could be reinterpreted to have meaning for pinning too. The language of the standard actually says something like, I believe the cookie should only be transmitted on a connection as secure as the one that it was set. So if it's set over pinning, maybe it should only be submitted over pinning, but obviously that's something that should be discussed and considered. And the final thing I think would be kind of my dream is that future standards in this space, during the process of working on the standard, it would be really cool if we had a way, the way people who are coming up with new user interfaces do user testing to do developer testing. Take some developers who haven't been following the standard at all, aren't the kind of people who would go to an IETF meeting, are busy developers who have like an hour a year to think about security of their site. See if they can figure out how to use the thing correctly, given a half-hour time budget and a few pretty loose docs on what they're doing. And if they're getting widely confused, that would be an indication that maybe the standard is going to run into problems down the road. So I know that's a pretty tall order. I said it's kind of a dream, but it would be neat if we work toward trying to proactively figure out how end developers are going to get confused when we're designing stuff. So that's all I had prepared, but happy to take more questions depending on time.
Take a couple.
Hi, Jeff Hodges. I was the lead author on the HSTS spec. This is awesome. Thank you for doing this. And Joe and I have talked about the paper a little bit. Too often there aren't survey papers like this done. More are happening, which is really good, but getting data on how things are actually used in practice is really, really useful and is wonderful. So thank you very much. Let's see, on a couple of things. So in terms of the preload list, in terms of getting in the list, the UI you put up there gets you into Chrome's list, which Firefox is leveraging, yes. But those new requirements about the 18 weeks and stuff were cooked up by the Firefox guys. They didn't originally, Chrome didn't originally have them, Atom didn't. And but that only gets you into 2 browsers lists, right? No? There's more, there's news.
Well, it's not news, I don't believe. So I believe Chrome's list feeds into Safari as well, but Safari never talks to me, so I'm not sure. And I also believe it will feed into IE when IE do it.
Okay, good.
And also it's Opera too, right? Because Opera is Chromium's network stack.
Okay.
So we've got everybody?
What about Vivaldi?
Who?
There's a new browser.
I don't know. I haven't heard from them yet.
Okay. So thank you. That's good. So that does kind of feed in, but an aspect of that is, yes, you're right. That's all ad hoc with the old boys network, and that's kind of the way things work these days. But that might be something to more formalize down the road. Sure. In terms of include subdomains, I will have to go back and count how many mail messages that topic involved, but it was a lot. And I think part of the aspect of your perspective versus the one we landed on, where it is not the default, has to do with tribes. The people in the room in designing HSTS were browser developers and large relying party and people who show up here, and we all felt we would be strung up and burned in effigy or in real life if someone up the DNS tree slapped include subdomains on, and there was policy boundaries, in other words, other administrative domains down the tree that all of a sudden got broken because they weren't, HTTPS, that would be really bad.
Yeah, but I mean, I guess our discussion is about defaults, right? Not what's possible, because it would be, if they were concerned about that, it would be possible for them to.
So I'm being told to sit down. But anyway,
get back up at the open mic. There's a person waiting in line behind you.
But so it's a very interesting question, and it was a lot of teeth gnashing over which way to go on that, and it's not clear which way is the better way.
Right.
Okay. Mark.
You can get behind me if you like. Mark Nottingham. Thank you for gathering this data. Again, very important. I very much appreciate the message in your last slide, which is about developer testing, and I think ops testing as well. I am a little bit concerned about the very low adoption rates we see for these new web security mechanisms, not only this, but also CSP and the W3C. And I think that we need to make them more usable, more understandable, more comprehensible, and more applicable to what they're doing. So please keep it up.
Thanks. Richard, are you in line or no? Okay, is it very, very briefly?
Yeah, very brief. So I think one of the takeaways from this, thanks for doing the work, but I think one of the takeaways is also about the interactions between these different specifications.
Yeah.
I mean, particularly in the web AppSec group, we've been talking about the interaction between mixed content and HSTS quite a bit. And I think we actually got it wrong in the initial specifications. So I don't know how we collect all of the different interactions that can come up before we go ahead and get things out there, but that's something we have to keep in mind.
Okay. So thanks, Joe.
Yeah. Thank you.
Adam.
Right, well, I've only got 10 minutes to do this, so I'll try to get through quickly, right? No pun intended. Right, so hello, I'm Adam Langley. Amongst other things, I work at Google and somewhat on Quick. So many of you will know sort of Speedy, which turned into sort of the basis of what then became HTTP 2. When we were first talking about Speedy at Google quite some years ago, the initial idea was not just to do what became Speedy. It was to sort of like boil the oceans, replace TCP, TLS, and HTTP, go nuts. Now, we scoped that a little once we realized how much work that would be, and Speedy pops out of the top of this. But sort of the remaining ideas were still there, and Speedy seemed to work out okay. So Quick is sort of the continuation of the original Speedy vision, where Speedy sort of replaced, complemented something HTTP 1.1, and Quick is replacing, complementing something TCP and TLS. Next slide, please. Okay, so this is the security area group, but the important point is Quick is primarily and dominantly a transport concern. It is full of transport people doing transporty things about congestion control and all that sort of stuff. But this is, well, at the time it was 2013, and even back then, pre-Snowden, security was not optional. Like the transporty people could not do transporty stuff without a security layer because we wouldn't let them put anything over that transport. So basically the Quick people came to me and said, we need a crypto, please make us a crypto. And so in 2013, there was this thing called Quick Crypto, which has been in Quick now for a couple of years. And Quick is used on an experimental basis between Chrome and Google servers right now on the internet. So it is something we're experimenting with. And sometimes your HTTPS traffic will be traveling over Quick if it's going between Chrome and Google. And in fact, it will not be TLS in that case, it will be Quick Crypto. Next slide, please. So this is sort of the Quick state machine in quite a lot of detail. And it's on its side because the point is not that you should be able to read it. The point is that you should just be able to weigh it compared to, next slide, please. So this is a TLS state machine, actually in much less detail from the Mac TLS paper recently. And this was the Java one, including all those red arrows, which meant that actually it was completely broken and Java's SSL never works. Next slide, please. Okay, so a one-slide summary. Quick Crypto is sort of trying to do what TLS does, but also supports zero RTT. So it's a fixed Diffie-Hellman sort of protocol, which is what TLS 1.3 looks like it's going to move towards based on this morning's TLS working group meeting. And so, the server has this block with a Diffie-Hellman public key in, and, it gets signed, and there's only one handshake mode. Either you're a client and you know the server's public key and you're correctly predicting it, and you basically just like send a packet at it, including sort of application data and stuff, and the whole thing goes in zero RTT, or you get it wrong. And at which point you get it wrong and the server says, you got it wrong, like here's some information to help you get it better next time, go away, I've forgotten about you. So there is only one mode. There is one handshake mode, and either it works or it doesn't. And if it doesn't work, then you do better next time as a client. Okay, next slide please. Right, so the practical upshot of this is that the one handshake mode is zero round trip. And TLS might talk about zero round trip, but Quick is a UDP-based protocol, so we're minus one round trips by sort of Quick standards, right? Because we don't have the TCP handshake on top of us. I threw away resumption, so just a simplification. It's faster than TLS. It's using code 2519, and it's forward secure to TLS's level or better, which is complicated, and I don't have time, so I'll skip that. Next slide, please. There are some references. It's been analyzed in a couple of papers. Next slide, please. Okay, so the important part of this talk is Quick Crypto and TLS 1.3. So TLS 1.3 looks quite a lot like Quick at the moment, which is no accident because the design space of zero RTT transport protocols is quite small, and I think you either look very much like Quick or I I think you're solving a different problem. Important, so Quick, as I said, it has this Diffie-Hellman block, which is signed by the server's key. In Quick, that is an offline signature. Like you can get the server's signed Diffie-Hellman block via DNS, via anything. The Diffie-Hellman block is kind of like an additional certificate at the end of the chain. So one important difference that TLS 1.3 has chosen is that they're not going to allow that because they're worried about people with HSMs, people who put their TLS keys in an HSM. The property that these people want is that if they have a point-in-time compromise, the attacker, while they have access to the HSM, can do all sorts of horrible things. But once they've detected and kicked that attacker out, they want to sort of recover, right? The HSM, you assume, never leaks the key. It only leaked Oracle access. So if the attacker has lost Oracle access, they've lost. But with Quick, that's not true, because when the attacker had access to the HSM, he could have signed a whole bunch of these Diffie-Hellman blocks with like timestamps into the future. It's like getting access to a certificate signing key. Now, so the advantage of Quick Mode is that you don't have to sign as much, right? You can sign one thing once and hand it to all of your clients for as long as that Diffie-Hellman thing is current. The disadvantage is HSM, whatever. TLS 1.3 went the other way on this, and so I don't know, Quick may have to update. Also, Quick had this anti-replay scheme, which had been analyzed by a bunch of internal reviewers and looked at by at least sort of one of these papers, and nobody noticed that it was complete nonsense. And it is. It totally, I mean, it's kind of embarrassing. I completely fucked that up. So that's crap. Is there a next slide? Okay, so the important message of this topic is basically for us to say that we needed this zero round trip TLS thing 2 years ago, and sort of we have it. And you might see Quick popping up in the rest of the IETF, and probably in the transport area, because it's a transporty thing. But we are not trying to get an alternative to TLS in the IETF through the back door through the transport area. Right, we invented it because we needed it, but I'm not proposing that Quick Crypto is a competitor to TLS 1.3. Quick as a transport protocol, like the crypto bit is just sort of this blob. It's a state machine that needs to run, and then it spits out some symmetric keys with which we can encrypt the packets with an AEAD and so forth. This little crypto state machine is currently Quick Crypto, but hopefully it could also be TLS 1.3. There are some things that Quick would need of TLS 1.3 for this to be possible. One thing to think about is that it's TLS 1.3, not DTLS 1.3. So Quick as a transport is providing in-order reliable delivery for the handshake state machine to talk about. So the handshake really, it looks like TLS. It's the crypto is not worrying about its packets being lost. We are worried about things like source spoofing, because it's a UDP protocol. Like someone can fire handshake messages at us from a spoofed source address, which is not a concern for TCP protocols. And that last point was just what I said, is that we are not looking basically to replace TLS here. Hopefully TLS can work for Quick, and if you see Quick pop up in the transport area, don't panic that the transport area are doing security stuff. Thank you.
Did anybody want to panic?
Thanks for talk, Adam, and the point about TLS versus DTLS. One of the things I've been thinking about doing as part of the 1.3 is trying to harmonize that initial cookie exchange between TLS and DTLS, so we don't have to have two client loads. So maybe offline you and I can chat and see if that would solve the problem of source spoofing.
Right. I mean, I think we're all meeting with the Quick folks tonight, right? So
you're right. Correct. We are. That's right.
Paul Hoffman, have you given the same presentation in TSVWG?
No.
Okay. So we're not the ones who would be the most panicked because we sort of trust you and like you and such like that. I've heard a number of transport people say, oh, Quick's coming in and it sounds like a replacement for TLS. TLS 1.2 even. So you may want to do the same presentation, although at less than 1/2 of an acre in front of TSVWG.
That was aimed to be at 0.7 acres because I only had 10 minutes.
I think there was last year, or maybe before that, there was somebody present Quick. Was it out in the transport area? Sorry?
Gianna might know.
Yeah, there was about a year ago. There was in transport area open meeting. There was a quick presentation, and just to answer Paul's point, DSWG will look to security area, and security area can say, you're fine with it.
Wes Rudiger. So I guess first off, two things. One, thanks for pushing the boundaries on looking into new stuff. I mean, experimenting with new stuff. One question about your deployment. You said that it's actually online today between Chrome and Google.
Mhm.
What do you display in the URL bar?
Users wouldn't notice. It'd be HTTPS.
So that's actually what concerns me, because fundamentally you're lying about the security properties that is actually going on with the transport. You're not using the same security properties. And so I understand the need to, maybe experiment and stuff like that, and you're doing it between your own stuff and your own server. But fundamentally, you're telling the users that they have one set of security properties that they're supposed to believe in, and then they all know what HTTPS is and trust it. And for most people, right, most people don't even notice the S. Most people don't even notice whether it's
Sure.
there. So I'm not really concerned about them. But for those of us that really do care a lot about security, I'd be pretty upset to find out that my data was being transferred in some mechanism that I had not heard of and was being blindsided by.
So so that would be a concern if the security properties we were aiming to provide were less. But we're not.
So, by the way, the mic lines are cut for this. But
Okay, that's an analysis issue, though. I mean, the thing is that it hasn't been given the same level of review by the same level of people. So, yeah, you can declare that it's the same or that it's better, but I'm not sure the entire world can agree with that until it's been properly analyzed.
Hopefully the mic works, yes. Allison Menken. Quick note that TCP Inc. is probably the transport place where transport protocols combined with TLS style things are happening. But also, I just had a clarifying question. Is the curve for the initial signature, is that not crypto agile? Is that for good, or is that because it's not in this? Is that kind of a thing that is agreed on between the consenting endpoints?
So you're asking about the curve for the signature that the server makes of its
Yeah,
config.
that's
So
right.
that's based on X509 cert. So it's either RSA or ECDSA, depending on which cert we use. And actually, we kind of prefer RSA in this case for its speed. That sounds odd, but it's true. Or ECDSA for its size, and we're not entirely clear which of those we like. But it's exactly the same as TLS because we're using the same certs.
Okay, the slide didn't read that way. I haven't read the spec. Thank you for the clarification.
Mark?
Mark Nottingham. I just wanted to say the semantics of HTTPS as a URI scheme are not bound to TLS. It's not an explicit relationship there. So with any of the hats you want me to wear, I'm happy to say I'm very comfortable with what you're doing there.
Yeah, I was going to defend that as well, not necessarily on the technical grounds Mark just offered.
Sorry, Joe, the mic line's closed. There
And-
will be open mic in a minute.
And also, even when it is TLS, we screw with TLS too. So
But that was what I was going to say. That's what I was going to say is when we roll out TLS 1.3, we're going to be doing experimental versions of TLS 1.3, and we're going to show the HTTP, and those are going to have had only some analysis, and we're going to show the HTTPS header, and so don't there's got to be some room for experimentation on that front.
Jan? Okay, thanks.
Thank you.
So, hi, I'm Jan. I would like to present our initial version of our draft for authenticated denial of existence in DNSSEC, this time called NSEC 5. Next slide, please. Why another authenticated denial of existence? Well, basically, DNSSEC is designed in a way that you can sign the zone offline, put all the signed data onto the servers, and don't have to do the signing on the servers on the fly. So this works fine. However, it works fine for names which exist in the zone. For names which don't exist, there is another mechanism which was initially called NSEC, and basically you take all the names in the zone, put them into a canonical order, take each consecutive pairs in this like list of names, and insert into the zone special records called NSEC, and sign these records. So if the server wants to prove that something doesn't exist in the zone, you actually the server sends a record which covers the name, and this record says there's nothing existing between these two names, which works fine, but it allows zone content enumeration. So basically, by following these records, which the server gives you, you can enumerate all the names which exist in the zone, including the types. There's also a mechanism called NSX3, which instead of the raw domain names uses SHA-1 hashes of these names. So the enumeration is much harder, but it's still possible because you can do offline attacks. So we basically propose NSX5 where this zone enumeration is impossible. At the moment you can prevent zone content enumeration even with NSEC and NSEC3, but you have to do online signing. And for online signing, you need to have the zone signing key on all the servers. And that's something we don't want to, and it's not necessary to NSEC5. Because with NSEC5, we add another type of key, which is used only to compute the hashes. And possessing the key doesn't mean that you can tamper with the content of the zone, but you, well, if an attacker gets in hold this private key, it just degrades the security of NSEC5 to NSEC3. So next slide, please. This is a picture how it works. Let's say we have a zone which contains just 3 records, ACOM, CCOM, ZCOM. The first thing we basically have to do is to compute something we call NSEC5 proof, which is in our draft full domain hash or RSA-based full domain hash of the original domain name. This is a value which is computed using the private key of the server, so no one except the server can compute this value. But the clients which have the public key available can verify that this NSEC proof is valid and it matches the name. This NSEC5 proof is used as an input for SHA-256 function, and basically the result is called NSEC5 hash. And this hash is used similarly as in NSEC3 to build the chain of existing names. The hashes are sorted, NSEC5 records are added into the zone, these records are signed, and that's all. Next slide, please. Basically, we need to change the DNS protocol a bit. This is not intended as a replacement for NSEC and NSEC3 because this NSEC5 adds some requirements as for performance of the servers. We want to have it as an alternative. We define 3 new resource record types. NSEC5 key, which is a record which holds the public key used to compute the NSEC5 proofs. This record is intended to be stored in the zone apex, similarly to DNS key. We also have NSEC5 resource record, which is an equivalent of NSEC and NSEC3. And these records basically build the NSEC5 chain. And then we have a resource record NSEC5 proof, which is not intended to be stored in the zone. It's never be in the zone, and is synthesized by the server during the responses. So when the server wants to disprove existence of some name, it basically computes the NSEC5 proof, puts it into the synthesized record, NSEC5 proof, and send it to the client with the NSEC5, so that the client can prove that the denial is actually valid. So we know that this increases it requires some additional work for the server and the clients. We also know that it increases the size of the messages. So another thing we added is a wildcard flag, which is an idea we borrowed from expired draft of NSEC4. Because with NSEC3, in the worst case, you will have all 3 NSEC3 records in the response. With this kind of trick, we limit this only to 2 records. So in the worst case, it will be 2 records. Next slide, please. And this is the last slide. What's the current status of the draft? Some sections are incomplete. We definitely need to complete performance considerations as soon as possible, because at the moment we don't know exactly what difference it is to use NSEC5 with respect to the performance and performance of the servers in comparison with NSX3. We also are quite unsure about the signalization of NSX5 support. At the moment, for simplicity, we use the same mechanism which was used when NSX3 was deployed, and that's defining an alias for algorithm number, for existing algorithm number used in DNSSEC. So in the parent zone, basically we can signalize by this new identifier to NSEC5 another resolver that we use some other algorithm, and the NSEC5 another resolver will treat the zone as insecure. But we don't like this way, so that's why I have it here. And we also are quite unsure about adding new algorithms into this specification, because for the moment we define only the full domain hash with SHA-256, and but there are other algorithms which exist in the research papers which might be useful faster. Yeah, I will read just the last point. Also, and on DNSOP there was raised an issue that we don't define a mechanism to distribute these NSX5 private keys to the slave servers, other authoritative servers. The question is, if it's in the scope, we don't think so, or I don't think so. So,
hi, Adam Manley. Sorry, I might be being slow here. When the zone is signed offline, you are creating NSEC5 records which match up sort of pairs of these hashes, right? And then is the DNS server, does it have this NSEC5 key online?
Yeah,
okay.
The authoritative server has to have this NSEC5 key online, but this key doesn't allow the server to tamper with the content in the zone.
So if I'm a server and I wish to disprove foo.com, I NSEC5 hash foo.com with the online key that I've got, and I tell the client, here's the hash of foo.com, which it can verify because it can get the public key, and also I give it the previously signed pair of NSEC5 hashes, which proves that there's nothing, right, that there's a gap where that hash should be. Thank you.
Exactly.
Oliver?
Hi, Oliver Clemson, ex-DNX, ex-chair with many burn scars from NSEC wars. I like the technology you are proposing here, but I think it is something that is totally not needed. For what I hear is message size is a much bigger issue than zone enumeration. And if people really want to do this, I see no other alternative than to follow the example I'm trying to do now in my implementation, to have everything signed on the fly at the edge using elliptic curve. And last time I looked, your papers don't support elliptic curve algorithms, so you're still using RSA algorithms. So I love this academic research and looking for a practicality, but in this case, I hope not.
Yeah, thank you. Well, as for the RSA used, we require, in order to make this work, we require something which makes deterministic signatures, while we need that there has to be only one possible signature per domain, per domain name and key. Because if we use it ACDSA with some deterministic random generator, then for one for one name and one key, there might be two different hashes, and the slaver could like fake the non-existence of some name based on the data which are validly signed by the primary server. Yeah.
So the lines are cut, and down the back next.
Okay, Ralph Faber, Nominum. So I was told a couple of years ago we need NSEC3 because NSEC you can do zone walking, and then some smart people came around and did zone walking with NSEC3. I mean, I'm not a crypto expert, but maybe some people in some years come around and also enumerate your technology. And from what I've heard in the talk is there is an existing possibility to counter that with the existing NSEC3 stuff. So given that everything that we do in DNS sort of rolls out slowly, and the ecliptic curve that has been defined for some time now still is not available for validation. So Why don't we just really go on, deploy the DNSSEC instead of kind of fiddling around with it more?
I don't know what to say for that, but
It's a comment. Eric?
Certain sympathy for the view just expressed. Correct me if I'm wrong, the entire source of this problem is the desire to do authenticated denial of existence, right? So if I simply was willing to not deny these sensitive domains, then this entire zone working problem would go away, right?
Yeah. Joe?
Joseph Bonneau. Yeah, interestingly, so we've been working on almost this exact same problem with the Connix project to do user key directories with transparency. We want to do authenticated denial of existence for a user. There is an elliptic curve based way to do this. It's a little bit not standardized, but it's kind of like a crypto trick that's well known. So I can chat about that after, but we went through the exact same. We were using RSA because ECDSA doesn't work by itself. There is a way to do it. It's just a little bit of a mess.
that would be great to talk about it. Thank you.
Yeah, I'll catch up.
Okay, great. Thank you.
So, thanks.
Better? Sure. Break the pink box rule. So that camera does move.
There's no podium, so.
If the camera finds you, then you're on video. Otherwise, you're not.
It's okay, it's a bad hair day. Don't need to be on video. My name is Ladar Levison. I'm from LavaBit. Just to follow up on the earlier presentation, the key that got pinned inside Chrome was used for a temporary download site that I put up that allowed people to download archives of their message store after the primary wildcard cert got compromised. And I wanted to ensure that the subdomain that was hosting those archives people weren't tricked into using the revoked/compromised wildcard key. Anyways, I'm not here to talk about that. I'm here to talk about a proposal that I'm still working on that I hope one day will end up as an IETF standard. Try saying that fast. It's for end-to-end encrypted mail. It's slightly different than what people are familiar with. I basically started out looking at how could I improve PGP or SMIME and quickly realized based on my design goals that I couldn't achieve what I wanted if I started with those specifications. So as a result, I've had to kind of do a lot more work than I anticipated, but loosely speaking, it's 5 specifications, a management record, which is very similar to a DKIM record, a SIGNET format, which is very similar to a TLS certificate or an open PGP public key, the DMIME standard, which is loosely based on SMIME or very similar to SMIME in that it provides a layer of encryption on top of a MIME message, could also be considered similar to open PGP MIME. And then 2 protocol standards, DMTP, which is similar to SMTP, and DMAP. At its core, this system is all about passing around RFC 5322 internet email messages, presumably in the MIME format. Should I? So, as you can see from the project goals, we're trying to do a lot of very new and interesting things when it comes to end-to-end encrypted email. Obviously, we've been able to do end-to-end encrypted email since the mid-90s. The problem is we're the only ones who know how to do it, as in the people in this room. Everybody else on the planet can't seem to figure it out. So what I'm really focused on is integrating what we need to into the protocols and into the formats that allow us to automate the key management, make the encryption process itself transparent, and design it in such a way that we can have end-to-end encrypted email become an ubiquitous fact of life without compromising or changing the way that people use their email today. Now, what I realized is that there are certain things that you need to do that are going to break certain ways that people use email. But what I tried to do was capture the most common use cases and make sure that people could continue using their email in that same fashion with this standard. Where I had to make choices, I decided to come up with definable points along the scale between security and functionality. And we call those account modes, and I can talk more about those this evening. The second goal was to minimize the leakage of metadata, and I'm not talking just about the message headers, but actually the envelope information, that is, who is communicating with who, which obviously breaks SMTP. And finally, because we're automating this system, I focused as much as I possibly could on making sure that we designed it in such a way that it was resistant to manipulation by an advanced persistent threat or large organization with unlimited resources. What I'm going to talk about today, because this is the security area, is the trust model, a little bit about the SIGNET format, some of my algorithmic choices, a couple of new and interesting things about the message structure, and then if I still have time, some of the binary details. I'd like to start by introducing a new concept. I call it TUFU. It's the idea that you have to trust the organization on first use. Loosely speaking, that means an individual message is tied to a user SIGNET, which is tied to an organizational SIGNET, which is tied to a DNS record, which is tied to a top-level domain record, or zone, which is tied all the way back to the global root. So loosely speaking, those bottom three steps are protected by DNSSEC, while the top steps are protected by the mail system itself. Now, what's interesting about this choice is that some CCTLDs are controlled by the countries that they're associated with, which means, for example, Russia controls the DNSSEC keys for .ru, which means if you happen to be a user in Russia on a .ru domain, this model doesn't quite work so well. Coupled with the fact that DNSSEC deployments remain in, I believe, the single digits, based on optimistic statistical gathering. So I couldn't also tie the deployment of DNSSEC to this system. It is the preferred automated validation path for at least the organizational SIGNET, but it isn't the only one. The business rule itself can be loosely expressed as there needs to be a primary authoritative source and then a second pre-authenticated source for validation and confirmation. Obviously, a DNS record protected by DNSSEC can serve as a pre-authenticated secondary source. So can a TLS-CA, or presumably in the future, a global ledger. The global ledger itself is my solution to this DNS problem. And I can talk about that a little bit more this evening, but just quickly, some of the elements that we've integrated into the formats, and part of the reason that we decided to go with the strategy of creating a new format is we have a concept of a chain of custody signature. That means once you download somebody's SIGNET into your local SIGNET ring, you can chain any rotations of their key information to the SIGNET that you already have stored locally. Which means once you start communicating with someone, it becomes impossible for that service provider to do a man-in-the-middle attack on that particular account without triggering a warning. We obviously still have the concept of assertions, which can be loosely described as the PGP Web of Trust model. And then, like I said, in the future, I hope to create a global distributed ledger that serves as an immutable reflective collection or source for what an email service provider is publishing on a user's behalf. Did you have a quick question?
Yeah, you should have just lost me a little bit on the trust hierarchy. Maybe an example would help. I want to send you. I have a bunch of software that I've downloaded that's the Prime software, and I want to. And I've never contacted you before, but I have your email address, and I want to send you a message. Can you just walk me through the interaction I have with the various network elements?
Sure.
I look through your slides. I don't see it further. That's why I stopped now.
the client, you would type in the email address of the person that you want to send.
Yeah.
Your email client, your MUA, would go out to the DNS system and look for this DIME management record.
Okay.
The presence of the record indicates that the domain is DIME enabled.
Okay.
Once it has that record, it also has the primary signing key for the organizational domain.
Okay.
It then goes out to the authoritative mail server for that domain, requests the full organizational signet, which can contain some additional attributes, and I'm going to talk about that more on the next slide, which will have secondary signing keys if a domain doesn't want to use the same signing key for user signets and messages. It can then request the signet for a user that it wants to send an email to, validates the signature on that signet against what it got from the organization, and then presumably either encrypts the message to that signet, or if it's an incoming message, checks the signature on the incoming message against that user signet.
Thank you.
I wanted to talk briefly about the signet format and some of the more interesting properties of it that are a little bit new and unconventional. The first thing you need to know about a signet is that it's splittable. There are three major components, two of which, a full signet being a superset of a cryptographic signet. Now, a cryptographic signet is exactly what it sounds like. It's 200 to 500 bytes and represents all the information you need to perform the cryptographic operations, that is, sending and validating messages. There is a superset, which includes what we're calling optional informational fields, and those make up the full signet, which also includes the cryptographic signet. So if you have a full signet, you also have a cryptographic signet. And you can split the two apart because the cryptographic signet carries its own set of signatures, and then the full signet carries a set of signatures over the optional fields plus the cryptographic signet. We felt that was important. That way, if somebody decides to stick a 1 megabyte image of their face inside their key and you don't want to save that on your device, you can just store the cryptographic information. And presumably when we get to a world where we have a global ledger, we wouldn't want the global ledger storing the full signet for everyone. Now there's a modifier, which is the identifiable signet, which is a third area that could be appended either to a full signet or a cryptographic signet, and is appended during or prior to retrieval, that allows you to compare the result you got back from the server to ensure it's associated with the identity that you're looking for. But it is also separately signed so that you can remove it from the object before saving the signet in your signet ring. That way, if somebody manages to get a copy of your signet ring in the future, they won't be able to determine everybody that you've been communicating with, which is why we made it separable. That's what I think of as somewhat of a new idea. The other thing to know about signets particularly org signets, is that in addition to carrying some identity information that is optional, like the name, the website, the address, it also contains some auto-configuration information, such as where your client should go to access your account, if a provider decides to advertise that. But it could also advertise something like, it has fields to advertise an onion address for access and or delivery. So if a service provider does want to integrate with Tor in order to defeat traffic analysis, that becomes relatively easy. The thing to know about signets that's been somewhat confusing to a lot of people are these informational fields. But loosely described, they just give somebody the ability to attach a vCard to their signet, so that when you type that address into your mail client, you can have some information about the person that you're trying to communicate with pop up in the client alongside. I was very focused on security first, but user experience second. The other thing to know about signets is that they're extensible. I realized very quickly that I couldn't solve everybody's threat model with a system that looked like and functioned like email. So the compromise that I made was making this format extensible in the sense that it allows a user and to a certain extent, an organization to advertise support for alternative communications protocols that are possibly peer-to-peer or use an alternative form of encryption. And it allows somebody to bootstrap two users who both support the same extensible extension to the system to bootstrap the communication to this more secure method. Presumably, I see it something like the presence protocol in XMPP, where you send a request and presuming both clients support it, the other person on the other side can authorize the request and bootstrap the conversation to possibly be peer-to-peer through something like Tor. And then you can use something like OTR to encrypt the messages, or SCIMP, or any of a number of real-time peer-to-peer symmetrically encrypted protocols based on a straight Diffie-Hellman handshake. Just briefly about my algorithmic choices. I mandate the use of TLS version 1.2. We allow our systems to connect in what I call dual protocol mode, which is over port 25 with a specially crafted start TLS command that bootstraps up, but in order to prevent something like TLS stripping or start TLS stripping, I decided to mandate the use of TLS because it just made good sense, and mandate this particular cipher suite to ensure that we have PFS at the wire level. We also mandate the use of RSA certificates of at least 2K or better. The primary signing algorithm is EDDSA with the ED 25519 curve, and you can see down at the bottom the baseline set of algorithms that we've chose for encrypting messages. Now the auxiliary or alternate set of algorithms is still up for debate, but the idea would be that if two users supported alternate encryption, that would be advertised in the signet along with their alternate asymmetric key. Now, just so you know what I'm considering, curve 41417 or possibly E521 for the asymmetric curve, skein or SHA-3 for the KDF/hash function, and for the symmetric primitive, probably Cha-Cha or Serpent. Adam?
Adam Langley. So why are you sort of 25519 based and got the Bitcoin curve in there?
Because we're using the Bitcoin curve for the actual encryption.
Right. Why? You just wanted, do you feel that's diversity?
Oh, yeah. So I wanted distinct curves for signing and for encryption, just so you couldn't screw it up and use the wrong curve or wrong key for the wrong operation. It would screw it up in a catastrophic fashion because you can't use a key for one curve to do encryption or signing on another curve. They don't represent valid points with each other. So it would just fail spectacularly. I also use the Bitcoin curve because it provides some rather interesting properties in the sense that now every dime address is also a valid Bitcoin payment address. Just briefly, I haven't figured out what to use or stipulate as an alternate TLS cipher. I guess I should ask you why you were up there, but is Cha-Cha 20 Poly 1305 that TLS draft, is that going to ever become a standard?
I hope so. I believe it's currently pending because the queue in the TLS working group is quite long.
It's expired. I checked just before the presentation to make sure, but I wasn't sure if it was you were waiting for it to become part of TLS 1.3. But I was thinking about going with that.
Okay, this is Sean. So actually at the TLS meeting, we, again, like Adam basically nailed it. We were waiting to clear out some things, and then we're going to start a working group adoption call shortly, so like in the next week probably. So chances of it moving forward are good, and it's primarily based on the MTI choices we made, was picking Cha-Cha as a shipment.
All right, then odds are if we go with Cha-Cha as the alternate symmetric algorithm for messages, we will probably also set that up as an option for TLS as well. One thing that's somewhat interesting is that we still require the use of implementing RSA just for the TLS connections, because there isn't really an established collection of ECDSA signed TLS certificates, at least that I know of. Just briefly, you can't see what's in those boxes, but each blue box represents a portion of a typical email message. What you need to know is that each box is separately encrypted with a randomly generated symmetric key, and that different boxes can be accessed by different parties. The author and the recipient can access everything, but only one side of the conversation, in terms of the origin or the destination server, can access one of the two halves of the envelope information or the signatures based on need. Now, I don't really have time to get into how the messages are actually encrypted, but I wanted to talk briefly about a couple of new and interesting things that I'm doing with these messages. One of the things that I was concerned about is that when you have ubiquitous encryption, you've got resource-constrained devices on high-latency connections trying to access encrypted messages, which means they need to be able to access just a specific piece of a message. But more importantly, they need to be able to verify the authenticity of a message without downloading the entire message first. So that created what I call shallow validation. Now, I guess it's important to point out that messages will carry a full content signature from both the author and the organizational domain, and then inside each individual chunk, the plain text buffer actually starts the first 64 bytes with a signature over the plain text data, which also means the first 64 bytes of every chunk is, while probably not cryptographically random, at least unknown to an attacker, because in order to know what the first 64 bytes of any encrypted chunk are, they would have to know what the plain text was, plus they would have to know the private key of the person sending it.
Adam Langley, as Kenny will tell you, the signatures are designed to provide authenticity, not confidentiality. So a signature over a plain text chunk may reveal what the plain text chunk is. I.e., if the signature is deterministic, then the same plain text chunk in two different messages would have the same signature.
No, they wouldn't, because they would be encrypted. There would be. I'd have to think about that, but
You certainly don't need to answer now.
It's inside the encrypted chunk. The signature over the plain text is inside the encrypted buffer. So there's an outer signature and an inner signature, and I'm talking about the inner signature. So you have to be able to decrypt the chunk just to see that plain text signature. And once you can do that, you can see the plain text anyways. The outer signatures, which are taken over the encrypted data, are encrypted themselves so that you can't fingerprint a message and figure out who sent it. Shallow validation I thought would be important to throw out here to you guys to hear your thoughts on it. But the basic idea is that the client would ask the server to calculate a hash for each of the individual chunks. It would send those hash values down to the client along with the tree signature. The client would combine those hashes and then compare them against the encrypted tree signature that the mail server itself wouldn't have access to in terms of the plain text signature. That would allow a client to do a validation on a large message without having to download the entire message. Then all it has to do in the future is ensure that the chunk it receives from the server matches the hash value that was sent previously, and then once it decrypts that chunk, also confirm the signature over the plain text. The final thing I was going to talk about is this other concept that came out of feedback, me talking to other ESPs, was the idea that bounce messages, when you receive one, before you accept it, you make sure that it includes a signature from your own organizational domain. Well, some organizational domains didn't want to have the entire message come back in a bounce. So there's this optional bounce signature that allows you to take a signature over just a portion of the message, either just the envelope and the meta information or the headers, or that plus the displayable content. And that's it. I'm skipping the binary details, but we have a barb-off scheduled for this evening at 19:30 or 7:30 p.m. for the Americans in the Royal Room, and I'd be happy to sit around and explain the details of any other aspect of the system or listen to anybody's suggestions for improvement.
So the one thing I got some feedback on was the fee signatures. They should be, I mean, Merkle trees should be totally fine. I mean, assuming you've got the construction right, but there's nothing. So, yeah, it's a standard technique.
Well, it's not how PGP or SPM work, so that's what I meant by non-standard. So, yeah, I don't view too many of these concepts as being radically new, so much as radically new in the sense that they're all being applied to email.
Hi, this is Paul Artus. Just a one-slide presentation, which I was hoping that the only thing you could read is the URL, but probably not. So maybe if you want to like enlarge it a bit. The LibreSon project implemented unauthenticated opportunistic IPsec as a first way of doing more defense against massive monitoring. So it implements the IPsec standard for auth null, which is in draft that hopefully will go into working group last call very soon. We've implemented this, so people who want to test this, please download the latest version of LibreSwan and pull the configuration from this oe.libreson.org website, and then you should be able to do anonymous IPsec. Obviously, the next step is to add various forms of authentication based on DNS and other methods. So if you're interested in IPsec, come find me in the next couple of days and I can demo it for you.
Hi, this is somewhere between an announcement and an advertisement. There's some work starting to be picked up in RAI on what we're calling secure conferencing. Next slide, please. So in a standard one-to-one voice video calling scenario, Alice and Bob talk to each other. They have a single shared key, or probably a set of keys, but they all derive from the same key material, and they use that to encrypt the data. So far, so good. Now what happens when you want to have a bigger conference? Next slide. So one thing you can do is you can do a mesh. So everybody can talk to everybody else. There's a pairwise key between every group of people. This obviously doesn't scale very well for historical reasons, as everyone knows, for the number of keys you have, but the more serious problem is the amount of bandwidth it consumes. So if you've ever done like a Google Hangout, you probably notice that the person who's talking is big and everybody else is small at the bottom of the screen, a postage stamp. Well, so if I have to send, so the guy who's talking is sending high rate video at like HD to HD. So I'm doing it to one person, it's fine. If I have to do it to 20 people on a call, not so fine. So that's not going to work for anything more than about 3 or 4 people on a call. Next slide. The traditional solution to this problem is uses called a media conferencing unit. So basically, everyone's connected to the central server, and you can ignore the key labels for a second. But basically, you send your data to the central server, and when you're the guy who's high rate, you send high rate to him, and he blows it out to everybody else. But he has a lot of bandwidth that doesn't cost very much for you. So far, so good. Now we want to add security. Okay. So there are 2 major options. One option is to have everybody as a pairwise key with the MCU. The other option is there's a group key that everybody shares. In either case, you have the problem that the MCU can read all the data. So that's not so great. It's not the worst thing in the world, but it's not so great. You went to a lot of trouble to get security, and now you've sort of added a new person to this communication. Next slide. So we like to fix that problem. And there's some work going on to do it. The basic idea is to split up the conferencing function into a key management server who everybody shares a key with, and for some reason they're trusted, and then maybe they're one of the participants in the conference, for instance, and the MCU whose job it is to actually disseminate the media. And so the MCU only handles encrypted data, and the key server is responsible for making everybody have the same keys. The reason you need a key server, by the way, is because if you have to have a single group key because you want to send up one copy of the media and encrypt it once, and that means basically making everybody's keys match up. So there basically are 2 models here that make sense. One model, as I say, is one of the conference participants actually is hosting the conference, and the other is these sort of outsourced scenarios where the idea is that I want to build a secure conferencing site, but I don't have all the technical infrastructure to operate the MCU. I want to host that in Amazon, and so I can subcontract the MCU part to Amazon, but I don't have to trust them carry the keys properly. So anyway, this is very initial work going on in Rye. My suspicion is it'll be chartered in the next 3 to 6 months. So we definitely love to get people's input, help, etc. in this design because it's a little tough to get it right. Thank you. Adam Langley.
Does the key server know the key?
The assumption is it has to, yeah.
I don't think it needs to.
That would be even better. Well, fuck.
Okay, you should find JCB as well, because this is a group messaging protocol problem of which much discussion has been done.
Okay.
Yeah, this is DKG, same rough scenario. If the concern is about throughput for having pairwise connections, you can negotiate a shared key pairwise, which is low bandwidth, and then use that and pass the high bandwidth traffic through the MCU.
Right, so that is the basic assumption, right? Is you establish pairwise shared keys and you use those to establish the group shared key.
But then the key server doesn't need to be involved in that process. Anyway, I'm happy to talk with you more about it later.
Yeah.
I got cut off on the line. The issue with, doing stuff like quick when the indicia in the URL bar, that's not something that I care about. Like if the security analysis is the same or similar, that's great. The thing I worry about is when you click on that thing and it tells you key exchange, cipher suites, things like that, lawyers, people I work with take that very seriously, and they may do things on that information. If they don't know what's going on underneath, that could be a problem.
It'll say quick.
Great. That's all I want.
I wanted to follow up on that as well, to DKG again. One of the concerns that was raised was that if you provide the lock that you're therefore lying somehow about the security guarantee. Well, TLS has had a series of failures, historical failures, and hopefully we'll avoid making many more of them. But you could argue that historically we've all been lying anyway, if you want to make that argument. And the point is what we're trying to provide, and what we're trying to provide is this confidentiality and integrity.
I mean, Quick has at least sort of mostly started with formal analyses of its cryptography. Now, it wasn't a formal analysis of its anti-replay, sadly, but the crypto apparently works.
Wes Hardiker, I was still going to let this go, but as long as it's back up again. So my concern was not, there's been plenty of failures all over the place for encryption protocols. Let's go back to Dash, shall we? The HTTPS specification says it's over TLS. If you go look it up in 28, whatever it is. The URI specification says it's over TLS. So to have HTTPS up there is just not, my only point was that it's not really what's happening underneath the hood if you're completely changing the transport out from underneath. I'm not even necessarily saying it's bad. As I said, it's actually good that we are doing some experimentation. But for me, being a security geek, I want to know that I'm being experimented on, and I don't.
So as a practical reality, we can't change the URL, right? We cannot change the scheme. We will say in the dialogue that it's quick, but we're not going to sort of float a big indicator because 99.99% of our users sort of don't care. You may disagree, but hopefully you can sort of understand from our point of view why we did what we did.
I understand the need for experimentation. As I said, I'm going to let it go, but it just doesn't match what the URI specifier and says.
If we could plausibly have deployed a quick colon // we would likely have done so, maybe. But I mean, the web will never be able to deploy another scheme ever again. And so yeah, so HTTPS is all we're going to have until the end of humanity.
Paul Wouters. I think this is quickly solved by a pop-up saying, once in a while we would like to do some experiments on you. Is that okay?
That pop-up appeared when you downloaded Chrome.
Ben Koenig, well, haven't there been experiments with not showing the scheme at all and just having the padlock or the padlock with an X or something?
Basically, if you're using Chrome, we're experimenting on you all the time. Like, we switched the Cypher to Cha-Cha for like all of our mobile users, and yeah, sorry, we're doing it all the time.
So it's important to distinguish between there are three things going on here. There's the thing that appears, there's the lock icon, there's the thing that appears in the URL bar, and there's the scheme. The scheme, for the reasons Adam says, is absolutely immutable because HTTPS means something in the browser security context, and so you can't screw with it. So no matter what the transport is, you must think it's HTTPS internally. Now you can put a random stuff in the URL bar, which will just annoy the users, but I mean, like, you gotta think it's HTTPS or you're broke.
Jeff Hodges, so just have a slightly different color of green, but for Wes, but this is all a layer 9 problem. As you said, you agree to it when you download it. You know, this is up level.
Does somebody have the blue sheet? Okay, now I gotta find it. Slides are